is integral from 1 to infinity 2 plus 3 e to the negative x all over x dx convergent or divergent? This is actually fairly easy. And to show you, I'm going to rewrite this as integral from 1 to infinity 2 plus 3 over e to the x over x dx. So notice that this right here for 1 to infinity is always positive. So it is adding to the numerator. And I do have a 2 here, comparing it with 1 over x that is divergent. I know that this, this whole thing is even bigger than that. So I can claim that 2 plus 3 e to the minus x all over x is greater than 1 over x. And we know that 1 over x from 1 to infinity is divergent. So I can say that by comparison test, 1 to infinity 3 plus, actually it was 2 plus 3 e to the minus x over x dx is divergent, Okay, so let's do another one. Let's do another example. How about something like integral from 1 to infinity 1 over square root of x cubed plus 3x to the second dx. All right. So do we know anything similar or close to this that we know is convergent or divergent? And we do. We know that integral from 1 to infinity 1 over x to the 3/2 is dx is convergent, Why is that convergent? Because this power is greater than 1. And why am I choosing that? Because the elephant in the room in our original problem is right here, square root of x cubed. Well, what is square root of x cubed? It's same as saying that x cubed to the power of 1/2, and that equals x to the power of 3/2. That's why I chose that. All right. So let me clean this. So now I can say that 1 over square root of x cubed plus 3x to the second certainly is smaller than 1 over square root of x cubed, because it has, we have a bigger denominator in here. All right, so let me go to the next page and claim that x cubed plus 3x squared certainly is greater than x cubed. Okay, between 1 and infinity, and those are the boundaries for our integration. All right, so now I can say that by comparison test, integral from 1 to infinity 1 over square root of x cubed plus 3x to the second is convergent. All right, I think we have time for one more example. So let's do, how about this? How about something like this? Is a interesting form from e to infinity 1 over natural log of x dx converges or diverges. Okay, so for this one, we could actually look at the graph. So if you look at the graph of natural log of x, you know that the graph of natural log of x is smaller than, x to the second. And so actually, as x is approaching, and I should say here natural log of x, as x is approaching infinity, the graph of x squared just goes way up. So so graph of natural log of x smaller than x squared is for x greater than or equal to e. All right. Now that we know that, also that from e to infinity, 1 over x diverges. Okay. Since p is smaller than or equal to 1. All right. So changing color, integral from e to infinity, 1 over natural log of x dx. Let's see. Yeah, I can look at the graph, or let's just say that I want to know that is this really greater than or equal to from e to the infinity 1 over x dx. So here I want to show that, let me go to the next page. I want to show that actually is 1 over natural log of x greater than or equal to 1 over x, And so if that's the case, if I cross multiply, I'm going to say is x greater than or equal to natural log of x. And the easiest way, at least for me to see that, is from the graph. So from the graph. All right. So I'm going to go ahead and claim that from e to infinity, 1 over natural log of x dx diverges by comparison test. Let's say, and we compared it with integral from e to infinity 1 over x dx. All right. It is of interest, that in general, well, something that you will see that graph of x squared is approaching the higher values of y much faster than natural log of x. And so to emphasize that, you can say is just put that greater sign twice. And then if you compare that with exponential functions, let's say some base to the x is growing much faster. And do we have anything else that grows faster than that? And we do, but it's not part of this course. And that would be x to the power of x. But this is not part of this course. Okay. Okay, I'll be making more videos for you soon. Thanks.